Madam Chair and members of the subcommittee. My name is Radley Horton. I'm a Lamont Associate Research Professor at Columbia University's Lamont-Doherty Earth Observatory. Thank you very much for the opportunity to participate in this important hearing. I'm going to focus my remarks today on how the anthropogenic activities that we've heard about that have warmed the upper oceans are causing sea levels to rise. So there are two primary ways that global sea level rises as a result of that ocean warming. First and foremost, the upper oceans have warmed the surface of the ocean a degree Fahrenheit since 1900. That warming has made its way down to about 3,000 feet. That literally causes the ocean to stand taller. It's called thermal expansion. The second centrally important process globally is what's happening to land-based ice sitting in Greenland, Antarctica, and in high mountain glaciers. As the ocean warms, it's literally wearing away at the dams or buttresses, if you will, that are preventing that ice from sliding in part into the ocean. As more and more of that ice on land melts and makes its way into the water, we add mass to the ocean, causing further sea level rise. So we've seen about 7 or 8 inches of sea level rise globally since 1900. And importantly, there's been some acceleration over the past 2 decades or so. As we look to the future, projections of sea level rise for, say, 2100, we see a big range. We hear about a most likely range in the last National Climate Assessment of 1 to 4.3 feet. In my remarks, I'm going to take an optimistic approach and just focus on what 1 foot of sea level rise would mean. As I say, a very optimistic take on it. And really, fundamentally, what I want to highlight is that even a little bit of sea level rise means much more frequent coastal flooding and much more intense and higher magnitude coastal flooding whenever you're having a storm. And as we can see from Figure 1 here, we're already seeing that nuisance or sunny day flooding is happening far more often than it used to across the U.S. coastline. For many locations, a 5 or 10-fold increase just over the last 2 generations and how often we're seeing these high water levels. From Miami to Norfolk, for example. These are events that flood people's basements, make it impossible for businesses to open for normal operations, prevent people from being able to drive home along their normal coastal routes. When these events are rare, we can call them nuisances, but at what point, if they're happening more and more often, do they become something more than that, something that impacts real estate values, the ability to fund key infrastructure? Now let's go to slide 2 and focus, as we look out to the future, at what just 1 foot of sea level rise by 2100 could mean. What could it mean for the really extreme high water levels that currently happen once every 100 years along various parts of the U.S. coast? These are the high water levels that determine insurance rates and zoning plans. And what we can see is across the whole U.S., high water levels that used to happen once per 100 years become things that you expect during the lifetime of the typical home mortgage. And in many places, every year or two, you could be seeing those high water levels occurring that used to happen once every 100 years. Again, this is with just 1 foot of sea level rise and no assumption about stronger storms. In reality, we expect the balance of evidence suggests that the strongest hurricanes probably get stronger precisely because of ocean warming. That would make these effects worse than what you see here. It's not just more frequent coastal flooding, though. It's also higher magnitudes of flooding whenever a storm happens. One recent study found that if the New York region had been precisely the same when Hurricane Sandy struck, except somehow the oceans had been a foot lower as they were 100 years ago, 80,000 fewer people would have experienced flooding in their homes. That's the impact of just a little bit of sea level rise. So this is also obviously a public health and safety issue. It means less time for people to evacuate around low-lying coastal areas, and for those unable to evacuate, it means greater risk of death, more damage to buildings, because those water levels are higher, waves are able to penetrate further inland. Along our assets are trillions of dollars worth, businesses, homes, hospitals, I-95, Amtrak, our airports. But the economic impacts are going to make their way further inland as well. U.S. taxpayers bear the brunt of the bill for these coastal flood damages, and our coasts are economic hubs for all activities. There are also national security implications that I hope we may have a chance to discuss. Far inland from our coast, extreme weather events are impacted by that warming of the ocean as well. We're loading the dice towards more heavy rain events and combinations of high heat and humidity that harm our most vulnerable populations and affect the economic productivity of our outdoor laborers as well. I've had the good fortune to learn a great deal from decision makers as well as young people eager to tackle these problems and learn more. For example, investors are demanding now that companies disclose their exposure to sea level rise. These experiences have convinced me that although we are fast running out of time, a window still remains open for the ultimate tipping point or surprise, specifically rapid societal action to reduce our greenhouse gas emissions and prepare all of us for these climate changes that are underway. Thank you for inviting me to testify, and I look forward to our discussion.